Okay, what's up, Inspired Vision? Welcome to Pre-Calculus, Week 22, Tuesday. It is time to learn some math. Now, why do we have a mic now? Because we are live from first period. So, Week 22, Tuesday. Here we go. We are learning determinants again today. Now, this should be a review from yesterday. We get a determinant from doing a square matrix, which we're using our AD minus BC to find the determinant. So we multiply AD minus BC. All right, so everybody in the room, try doing the determinant of 2, 5, 7, 1. What numbers am I multiplying first? 2 and 1. Then I'm going to multiply 7 and 5. So your answer should be what? Good. Negative 33. The reason why it's not negative 37 is because your 2 is positive. Okay, easy, easy. Now we're going to build onto this today. So we're going to make this a little harder. And the only thing you should have in your notes right now is this one example. Easy, easy, because everything we've already written down. Okay, next. This is something brand new. It's called Cramer's rule. I know it looks like a lot, but I need at least the top, Cramer's rule, for 2 equations. Then I need what's in the middle of the screen, talking about your x and your y. Now, to make sense of these letters, though, you kind of need this equation to make sense of the letters. But here's what's going on. Actually, I'll give you a second to write it down, then I'll explain it. All right, now this looks a little different. Still giving you time to write it down, but this S and this T just stand for my solutions. The S and T are my solutions. So all they did above the X is put the solutions instead of your first column. So all they did is they took these solutions here and put them in this first column. So they kept the second column the same. Now that's what you do for X, and the reason why is because they replaced the X. For Y, they took the solutions and put it in the Y spot. Go ahead.
Is it saying that's the absolute value of those lines?
No, that's the matrix. So we're going to do, we rewrote the matrix here, and we kept the original matrix on the bottom. So this is the original. And this is your new
Original?
matrix.
Original?
I'm done.
Messed up line.
Thanks, appreciate it. Everybody's a critic.
Okay, start writing right.
I need a slip.
Oh, you're solving linear equations using your matrix. I'm good? Oh,
Careful what you say. All right, everybody ready? Let's see this in practice. Oh, there we go. I don't even have to worry about spelling it right. All right, now, here is the other thing before we start the next problem. write down, because you're going to see this notation in your homework. If they write dx over d, that means you're finding the determinant of x and divide by the original determinant. So that's the reason why they reordered the matrix here. And you'll see it in this notation right here. Now, before I show you a question though, we already know how to find solutions to the system, right? We actually know two different ways. We know reduced row echelon form, which takes a lot of steps. We also know to use the inverse. So this is a third way using matrices to find solutions. Okay, maybe you'll find it easier. We'll see. We'll see. But I got to teach you the steps. All right, here we go. Easy question. So we have that x plus 3y equals 5, and 2x minus 3y equals negative 8. The very first thing we do is write our matrix. Now, why didn't I write the whole thing? Because for the determinant, we only want the coefficient matrix. We're not going to use the solutions yet. And how do I find the determinant of that? You multiply these two together. And then you subtract multiplying these two together. So what is our answer? Negative 9. Okay, now here's what's new. If I'm trying to solve for x, I'm going to forget about that negative 9 for a second. I'm going to rewrite my determinant for x by using my answers right here. So 5, negative 8 replaces your first column.
Algebra 2.
She should be. All right, now, how do I find the determinant of this now? Same thing. You multiply 5 times negative 3, which is negative 15, and then subtract this answer, which turns into plus 24. So that becomes what?
How is it plus 24?
How is it plus 24?
Oh, okay. So it's negative 8 times 3, which is negative 24. But then you're supposed to subtract negative 24. So it turns into plus 24. Good question. So this was originally negative 24, and then I subtract negative 24. That's the reason why it turns into plus. So our answer is 9. Now, that wasn't too difficult. The only thing I have to do next is write this as a fraction. So when you're finding x, you're going to put this answer on top, this answer on the bottom. So let's see if my PowerPoint, oh no it doesn't. Okay, so we're going to do 9 divided by negative 9. So that makes my answer negative 1. So that makes my answer for x negative 1. It's a little bit different way of finding solutions. Okay, we're going to do the same thing with y. We don't have to refine the original determinant, which is this one. We're going to keep that as the bottom, but we have to rewrite our y matrix using our solutions in the second column, because that's where y usually goes. Anybody want to tell me what the determinant of this is?
Don't do that.
I'm not going to call y'all out. Just volunteering. No, you can't.
Nobody see you.
What?
Nobody saw you then.
Oh, I'm sorry. Sorry. It's a one-time only thing. All right, so we're going to multiply 1 times negative 8 and then subtract multiplying 10. So our answer is negative 18. Now, remember, this is our, I'm going to change colors here, just so you can see that this is different. This is our new top. Bless you. So this is going to be negative 18 over negative 9. Bless you. So our answer for y is positive 2. Because the two negatives cancel each other out. Alright. So, that wasn't too bad. I think I have one more of these 2x2 matrices before I have a 3x3. Oh, there's the answers right now. Everybody ready? Okay. Oh, if you want to write your solution as a coordinate, because remember we're talking about systems, so we're trying to figure out where the lines cross. There's your coordinate. Negative 1, 2. Okay. There we go. This is where we're going to step that up a little bit. Oh, we are so happy. Okay. All right. Here's the only thing I want you to pay attention for. Don't write this down yet. All it's saying is if I have your X, your Y, your Z's, and you have your column of answers, to write and find the determinant for your X, you're going to do this. You're going to replace your first row. Or sorry, first column. Yeah, write what I'm at the bottom of the screen. Actually, write everything in this box. You don't have to write the top of the screen. Okay, so basically we're going to apply the same rule as the 2x2 matrix, but when we find the determinant for X, we replace the first column. For Y, we replace the second column, and for Z, we replace the third column. So we're going to do just like we did yesterday, but we're going to do it twice for X, for Y, for Z. Put what's in the top part of the box, also in your notes. That's key to finding the answer. Okay, 30 seconds, and then I'm going to show us a question. By the way, before I show you our question we're doing in our notes, on your homework, the ones that say evaluate and they give you a 3x3 matrix, this is what they want you to do, these steps. But you also have inverse questions on your homework. You're not doing this for inverse questions. For inverse questions, you can use your calculator.
What about the expand by minus?
Say that again?
It says expand by minus 1.
Oh, same thing, same thing. Expand by minors is what we're about to do. Because that's how we're going to solve these. We're going to do it by expanding. Okay, here we go. Here is a system, and it's actually a pretty easy one. You're going to find this pretty easy, as long as you set up your coefficient matrix right. So we have negative 2x plus 1y minus 4z equals 4. And we have 5x minus 2y, we're missing the z, so we're going to put a 0 there, equals 18. And then 1x, missing the y, so plus 0, minus 5z equals 17. Now, I actually find it easier to write the augmented matrix first. So let's see if I have that. Yes, I do. There we go. So here's the augmented matrix because it's the whole thing.
Do we need to put that one column, that column?
No, you don't. You can put them side by side. Here, I'll even. There you go. All right, now we're going to find the determinant, the basic determinant first. So we're going to do negative 2, 5, 1, 1, negative 2, 0, negative 4, 0, negative 5. But our first step is to rewrite the first two columns. So that would be, I don't know, I guess I'll close the bracket here. Negative 2, 5, 1, 1, negative 2, 0. Alright, if I wanted to find the determinant here, let me change colors. I want to multiply these numbers together. Alright, if I multiply those numbers together, I should have negative 20. And this is why this problem is actually pretty easy. If I multiply this diagonal going down, what do I have? 1 times 0 times 1.
0.
0.
Positive 20.
Wouldn't it be positive 20?
Yeah, because the two negatives that cross each other.
Uh-huh. And then you have another negative.
Oh, never mind.
It's okay. Trophy points for trying.
Like, we didn't see the negatives.
It's okay. Okay. Then 1 times 0 times 1, that's 0. So this is going to be plus 0. And then we have 4 times 5 times 0, which is another 0. Okay? This is why this is pretty easy. Then I need to multiply going up. But let me change colors. So this time we have 1 times negative 2 times negative 4, which is 8. Then 0 times 0 times negative 2, 0. And then negative 5 times 5 times 1, negative 25. Okay, so if I get this answer, it's negative 17. If I have this answer from the begin with, I have negative 20. What am I supposed to do with those two answers? Subtract them. So we have the determinant is negative 20 minus negative 17, which is really plus 17, which gives us negative 3. Okay, I'm writing small because I'm going to put more on the screen. Because once we find the main determinant, and this is our main determinant, remember this is the number we're going to use for the bottom of each of our fractions. Now let's find the top, and we're going to solve for x first. So x, we're going to rewrite our matrix to look like this. 4, 18, 17, 1, negative 2, 0, negative 4, 0, negative 5. Hang on, let me make some notes. Sorry. Okay, so that's the matrix we need for x. I'm going to rewrite my first two columns just like here, so just like my original step 1. 4, 18, 17, 1, negative 2, 0. Then I'm going to do my step 2 again, so I'm going to multiply going down. 4 times negative 2 times negative 5.
40.
Yes, positive 40. I'm going to write, where can I can put it right here. I'm going to write it as dx because we're finding the determinant of x, and this will be negative 40 to start off with.
That'd be 40.
Positive 40, just kidding. Positive 40. Now the next line going down is very easy because it's just 0. And the next line going down is also very easy because it is 0. Alright? So, on your quiz this week, if I ask for just dx, this is kind of how I'm wanting you to start it, but we got another part we need to do. What's the next part? We need to go up. So we need to multiply 17 times 2 times 4. And it is positive or negative? Then the next number, 0 times 0 times 4. And then we have negative 5 times 18 times 1.
Would be negative 90.
Good. Alright, we need to get this answer. The first one was easy, that was 40. This answer is going to be 46. Okay, now, once you have your two answers, what are you supposed to do with them? Subtract. Which is negative 6. Alright, now we have everything we need to get our answer. Our answer is always going to be in this format of dx over d. So this answer goes on top. So that's negative 6 over negative 3. Two negatives make a positive 2. Okay, that wasn't too bad. It's about what I'm going to give you on your quiz for this question.
So how do you know you're looking for dx?
Well, good question. This says solve the system of equations. We only have x. We still got to find y and z. But it's two more matrices, and this is why this is your only example of like this we're doing today.
So we have like multiple questions of these on the homework?
Why? Why do you need us to be?
I love you. Preparing you for college.
Que loud so we can hear me?
No. Alright, here we go. Now, if we find y, this is the same question, by the way. This is our original determinant that we found on the previous screen. So nothing to write yet. We now need to find y. So this right here is to find our y. Because we found our x, now we need to find our y. Okay, so to find this, we need to rewrite our first two columns again. Let me erase that so we've got a little bit of space. So negative 2, 5, 1, 4, 18, and 17. Okay, I'm not going to write the steps out. We're supposed to multiply going down first. Bless you. Our first number is 180. Now keep multiplying down. Our second number is very easy. Keep multiplying going down to find the third number. And this time we have negative 340. I'm going to go ahead and get my answer to this before I keep going on. Negative 160. Okay, now I'm going to go up. I'm going to change colors. 1 times 18 times negative 4. Wow, good job. Then this one is 0. And then this one. Negative 100. Okay, I'm going to get this answer, and that is
Negative 170.
good. Now, I have to remember, I have to subtract both of these answers. So that's negative 160 minus negative 172.
Would be 12. Negative 12. No, 12.
Positive 12. Good job. Oh, that's cool. All right, now, that is supposed to be my top. So to find your dy, to find your answer for y, it's the determinant of y over the determinant of the whole thing. So that's 12 over negative 3,
Which would be negative 4.
negative 4. Okay, one more answer, and that's z. Here's what we need for z. We replace the third column. Then we rewrite the first two columns. Okay, we're going to multiply going down first. First number is 68. Second number is 18. Third number is 0. Get this answer before I keep going on. Should have 86. Now I'm going to going up. So that is negative 8. Negative 36. Plus 85. Okay, that should be 41.
Isn't it 0?
It's 18 times negative 2 0.
Good job. You did that on purpose.
Like that.
True, I didn't.
Don't like to your viewers. They have hope. They have hope in this.
Okay. All right, now this is negative 8
It's 77.
plus 85, which is 77. All right, finally, let's subtract these two numbers,
9.
which is 9. Remember that this is my top because this is my dy, dz. So that's going to be 9 over negative 3. So my answer for z is negative 3. Okay. Here's what I'm going to do. I am only going to give us one more question. Okay, everybody ready? Alright, now, I'm just changing the screen so you can make sense of this. Our matrix that we started off with, nothing new here, is this solution as a coordinate. I know you've never seen a coordinate written out like this before. It's because we have x, comma, y, comma, z, and this is for a three-dimensional graph. I'm not expecting that when you write your solutions, but if you remember to do that, that's even better. Something else that's important is your determinant cannot be 0. If it's 0, then we have something inconsistent. Just write determinant cannot be 0. Because then you would be dividing by 0, and the main rule of math is you can never divide by 0. Alright, I'm going to make the next slide our last question. Here it is. Here's what I want you to do in your notes. Just write down this triangle. Draw. Thank you. XY axis. At the middle of the XY axis, but 0, 0, put that as Miami. Then we have Bermuda at 938, 454, and Puerto Rico at 900, negative 518. These points are representing coordinates on a map. Ready?
What planet?
We got 0, 0, 938, 454, 900, negative 518.
Was Puerto Rico on the 3 or 2? Negative.
Positive 900, negative 518.
Talking about on the axis. See, it's negative 1.
Oh, it'd be the fourth. Is that what you're asking?
No. You see how it goes down?
Down here?
Yeah, go to left. All the way to the left. 2, 3.
Oh, okay. That's what you're asking. Ready?
No.
Okay, now this question, I'm not changing the slide just yet, but this question is kind of like yesterday. The whole point of this question is figure out the area of the Bermuda Triangle, which is where navigation systems tend to mess up for airplanes and ships. Now to find area, we're going to do this question just like yesterday. This problem is actually going to be pretty easy because we're going to have zeros in it. Now the first thing we're going to do is write this as a matrix. These points as a matrix can look like this. Take your first point, 938, you put this in for the X column and this for the Y column. Then you're going to put ones for the Z column. Okay, then you take your second point, you put it for X, Y, and then your third point, X and Y.
And then you write the first two numbers also.
Good. Then to find the area, we're going to find the determinant. And the way we're going to do that is to expand the first two columns again. All right. Now, we're going to do this just like before. We're going to multiply going down. These are going to be big numbers, but it's okay. The first number we have is negative 485,884. The second number is a lot easier because it's just 0. And third number is a lot easier because it's just 0. Alright, next, we're going to multiply going up. 0. And then finally, we multiply 900 times 454.
480,057.
Alright, now we need to subtract both of these numbers. And we get negative 894,484. Now we have one more step. To find the area, we have to think of a triangle. Triangle is 1/2 base times your height. But instead of using base times height, we did 1/2 of our determinant. Now the reason why there's a minus sign right here is we're going to multiply by negative 1/2 because we can't have a negative area. So we're just going to multiply by this by negative 1/2 or divide by negative 2. Either way you want to think about it. But our area for this Bermuda Triangle is 447,242 square miles. Okay, that's it for today. Till next time.